Good morning, guys. Happy Friday. So today we are going to be doing a lesson on trig inverses, okay? Inverse trigonometric functions. All right, so I have here a little chart that I guess I could put up. I'm not sure you really will need it, but so inverses are used to find angles, okay? So as we learned inverses in the past, it's kind of like the undoing. So if you ever need to know what angle will give you a certain ratio, right, or trig value, that's when you use inverses. So if you ever have to ask yourself what angle, that's when you're going to use this, right, to find angles, okay? So not the legs, not ratios, whenever you need to find the measure of an angle, okay? So here is the notation. Right, you'll see it's like almost looks like a little -1 exponent, but it's not. Remember when we did this, I think we did inverses, yeah, with remember the cupcake problem and all that, right? So here, this is the symbol for inverses. I'll show you in a few on your calculator what it looks like. Cosine inverse, tangent inverses. A just means the angle. They have an A here. It could be, anything else, but that will give you the measure of an angle. Here they're calling the measure of the angle theta, okay? So I'm going to show you what I mean, okay? Oh, another thing here, the inverses are also called, like when I was in college, they always called it this, arc sine, arc cosine, arc tangent. All right, so if you ever see that, sometimes the wording in different books or different tests are different. This means the inverse, okay? This means arc tangent, okay? Arc cosine, arc sine. All right, so I have some problems written down on my paper here. So if you ever need to, so for example here, find the measure of the indicated angle to the nearest degree. So notice they give you the side lengths here, but they want to know what is the degree of this angle. All right, so I have some of the problems written here so I can do them for you. All right, so find the measure of the indicated angle to the nearest degree. So first I have to figure out which one, as soon as you say, okay, I need to find an angle right away, you have to say to yourself, I'm going to use the inverses, okay, the trig inverses. You're going to either use sine inverse, right, arc sine, arc cosine, arc tangent, one of those inverses. How do I know which one I'm going to use here? Well, I have an opposite side and an adjacent side, so that's how I know I'm going to use tangent, all right? So it's basically like saying what angle, right, anytime you write that, it's like what angle will give me the tangent of 27, right, opposite over adjacent, right? So you could put this in your calculator like that. I'm going to show you that in a second, all right? So let me repeat that. What angle will give me the tangent of my opposite is 27, my adjacent is 38. So now let me show you the calculator. You will see right above the sine, cosine, and tangent button is the inverses. Do you see that? The sine inverse, cosine inverse, tangent inverse. So right now I want to put in this in my calculator. So I'm going to put the second button, right, and then press tangent, and you'll see, oh, let me turn the calculator on, that would help. The second button, and then tangent, and then you will see it'll pop up, the little inverse, okay? And then I'm going to put, what was it, 27 over 38. So 27 divided by 38, and enter, and there you have it. It says round to the nearest degree, so it's about 35-degree angle. So it's going to be about 35 degrees. So that means that this right here is 35 degrees. Okay? And just for future, if this is 35 degrees, how do I find this one if I needed to find the other angle? You just subtract 90 from 35, and that will give you, this one here would be 55, right? I'm not asking you that in this problem, but it might come up. Okay, let's do one more. Find the measure of the angle theta. So I worded this one a little bit differently. So here's my diagram here, my triangle. They want to know what is this theta just represents the angle. What is the measure of the angle? And again, as soon as you need to know what the measure of an angle is, you should say, all right, I have to use inverses. Okay, so which one am I going to use here? Well, I have opposite side and a hypotenuse, so I'm going to use sine. All right, so arc sine, right, or sine inverse of, what do we got? Opposite is 40, hypotenuse is 42, right? And what is that going to give me? You can put this in your calculator just like this. So I'm going to go over here to my calculator. I'm going to put second and the sine button, right? So the sine inverse of 40 over 42 is about 72 degrees. Okay? So this is 72 degrees in there. Okay, so that's pretty simple, right? Okay, so now I have a word problem here we're going to do. So a lot of the times you have to draw your own diagram. Sometimes they're nice and they give you like a little drawing, but a lot of the times they don't. So you have to just kind of think about real life, what the situation would look like, and draw it, okay? So a painter needs to lean a 30-foot ladder against the wall. Safety guidelines recommend that the distance between the base of the ladder and the wall should be half of the length of the ladder. To the nearest degree, what acute angle should the ladder make with the ground? All right, so I started to draw this here on my paper, so let me just start here. A painter needs to lean a 30-foot ladder against the wall. So if you're confused as to how to draw the triangle, just think. Here's a wall, right? And here, don't mind my ladder, but that's supposed to be a ladder. The ladder is leaning against the wall, and it's a 30-foot ladder, right? So that means this, the hypotenuse, is 30, okay? What else do they say? Safety guidelines recommend that the distance between the base of the ladder and the wall should be half the length of the ladder. So where's the base of the ladder? The base of the ladder is here, and the wall. So they're saying that this distance should be half the length of the ladder. So that means that this distance should be 15. The base of the ladder and the wall. Okay? And then we want to know, to the nearest degree, what angle should the ladder make with the ground? So where's the ladder and the ground? Right here, right? This angle. They want to know, what is this, right? You could put a theta in there, or you could put an x in there. And if you prefer to see an x, right, you could solve for x there. All right, so what am I going to use? In this case, I don't have an opposite side. I have an adjacent side and a hypotenuse, so now I'm going to use my cosine inverse. So I have my cosine inverse, right, of adjacent over hypotenuse, right, equals, if you notice that this is 15 over 30 is 1/2. If you put 1/2 in here, that would be fine too. Okay, so now I'm going to take my calculator, right, and I'm going to put second cosine inverse of 15 over 30 is 60 degrees. Exactly 60 degrees. Okay, so that means this is 60-degree angle here. All right, so I am going to post an assignment that's going to have probably some word problems like this, and then just some basic problems like the ones we did here. If you have any questions, I'll probably also, I think I'm going to give you some like this too, or maybe I'll save that for Monday. If it ever says solve this triangle, that means you have to find all missing sides and all missing angles. So that means you could use trig to find the hypotenuse. You can use Pythagorean theorem to find the hypotenuse. Then you're going to have to use an inverse to find one of these angles. And then you can use another trig function to find inverse to find the other angle, or you can just use subtract from 90 degrees to find the other angle. So there's different ways to do it, but if I ever tell you to solve a triangle, that means find everything that's missing. All right, so that might be on either this assignment or maybe the next one. Have a great day. Let me know if you have any questions. Enjoy your weekend.